Fundamentals of Synchronous Machines Training, powered by Tonex.com. Fundamentals of Synchronous Machines Training course will teach you the fundamental operation and modeling of synchronous machines as one of the most interesting types of AC machines. This course will briefly introduce the topics related to magnetic circuit theory and moves to the advanced materials related to synchronous machines, mathematical models and derivations, application, parameter calculations, and finally principles of synchronous generators and synchronous motors. Fundamentals of Synchronous Machines Training course simply teaches you the necessary information related to magnetic materials such as inductance, reluctance, energy concepts, permanent magnets and AC induction. The audience in Fundamentals of Synchronous Machines Training course will also learn about rotor angle definition, magnetic saturation in core, mechanics of motion, swing equations, inertia constant, frequency response of the synchronous machines, parameter calculation in induction machines, per-unit representation of synchronous machine equations, air gap MMF, effect of multiple poles in synchronous machines, structures of armature and field, rotating MMF in synchronous machines, machines with permanent magnets, magnetizing reactance of synchronous generators, short circuit ratio in synchronous generators, voltage regulation, and more. Audience: all individuals who need to understand the concept of AC machines. Power utility engineers working with different machines. Test engineers working in power industry. Engineers seeking PhD and graduate studies focused on electrical machinery. Power traders to understand the power generation and load systems. Independent system operator personnel. Faculty members from academic institutes who want to teach the electrical machinery course. Investors and contractors who plan to make investments in power system industry. Professionals in other energy industries. Marketing people who need to know the background of the products they sell. Electric utility personnel who recently started career in power systems or having new job responsibilities. Technicians, operators, and maintenance personnel who are or will be working on power system related projects or power plants. Managers, accountants, and executives of power system industry. Scientists or non-electrical engineers involved in power system related projects or proposals. Training objectives: understand the fundamentals of magnetic materials. Describe the operation of synchronous machines. Explain the different applications of synchronous machines. Differentiate the operation of synchronous motor and generator. Derive the mathematical equations related to synchronous machines. Study the dynamics of synchronous machines. Model the generators in complicated power systems. Understand the synchronous generator equivalent models and applications. Describe the synchronous motors and their applications. Calculate the efficiency in synchronous machines. Test the synchronous machines to find the parameters related. Implement dynamic models for synchronous machines. Study the advanced courses related to electrical machines. Training outline. Introduction to magnetic circuits. Introduction to synchronous machines. Operation and modeling for synchronous machines. Synchronous generator. Synchronous motor. Hands-on workshops and group activities. Labs. Workshops. Group activities. Sample workshops and labs for fundamentals of synchronous machines training. Synchronous machine modeling case in Simulink. Synchronous generator modeling in MATLAB. Synchronous motor operation. Unbalanced synchronous motor operation. Power system case study. subsynchronous resonance in synchronous machines. Voltage control by generators case. By taking this course, you will understand the operation and modeling of synchronous machines, including the detailed mathematical representation of stator windings, rotor windings, stator and rotor fluxes, voltages, transformation from ABC to co-reference frame, effect of damping windings in modeling, and phasor representation of synchronous machine equations. The training course will then focus on the synchronous generators as the main part of power generation units in traditional power systems. Detailed information of synchronous machines will be taught to help you understand the equivalent circuit for synchronous machines, concept of leading, lagging power factors in synchronous generator, armature reaction, calculation of powers, and operation of single generator connected to an infinite bus, SMIB. Call us today at 1-972-665-9786. Learn more about course audience, objectives, outlines, pricing. Visit www.tonex.com for more information.